Hey AP Calculus, we have a new lesson for you. It's the second one from section 3.3. All I'm going to be doing is extending these ideas of product rule, quotient rule, and just practice with first and second derivatives and all the good stuff. So, first thing I want to do is check out number 43 on page 116. The directions state, solve the equation capital D subscript x of y equals 0. Now, we have to translate this into something that probably makes a little more sense to us. dxy is the same as y prime. So I'm basically taking the derivative of this rational function right here and then setting it equal to 0. Solve the equation, then you're done. So if you recall, quotient rule stated bottom times the derivative of the top minus the top times the derivative of the bottom divided by the bottom squared. So I'm going to have x minus 2 for my bottom times the derivative of the top, which is going to be 4x plus 3. So this is bt prime right here. And then I subtract the top, 2x squared plus 3x minus 6 times the derivative of my bottom, which is just 1. So nothing will change inside there, except it's going to have a negative go through. The bottom square is just going to be x minus 2 squared. Simplify the top. I might just do that off to the side. X times 4x is 4x squared. X times 3 is plus 3x. Negative 2 times 4x is negative 8x. Negative 2 times 3 is negative 6. Then you distribute a negative 1 to all the parts inside here. So just change the sign of everybody inside here. So that's going to be a minus 2x squared, a minus 3x, and then a minus 6, so a plus 6. That gives us 2x squared. The positive 3x and the negative 3x will cancel out. You got minus 8x, and then these two cancel with each other. So this is now the numerator of my derivative. Now, solve the equation y prime equals 0. So I'm going to replace my y prime with a 0. And now we've got to do some time traveling back to when you solved equations that had this kind of setup to it, set equal to 0. So here's the deal. The bottom just gives us domain issues. X minus 2 squared equals 0. These solutions to this equation are just domain issues. It's actually, you can't be that value. So what you do is you'd say disregard the denominator. Disregard that and solve the equation 2x squared minus 8x equals 0. These will give you the zeros to that equation that you're looking for. So how do you solve the equation 0 equals 2x squared minus 8x? Factor out a 2x. You're left with x minus 4. So your two solutions, here, you guys might not be able to see very well. Excuse me. Is that better? Maybe. All right, so 2x equals 0, x minus 4 equals 0. You can divide by 2. You get x equals 0 as your final answer. And you can add 4 to both sides, which gives you x equals 4 as a final answer. That's it. All right, let's check number 49 now. 49 has 3 parts. The first part says, using quotient rule, find dy dx. So part A, I'm taking the derivative with respect to x of both sides, but I'm being forced to use quotient rule. So we just talked about quotient rule on that example. Before I get started, though, I'm going to rewrite the cube root of x squared as x to the 2/3 power. So dy dx equals bottom times the derivative of the top, which is 2x minus 3. And then you subtract the top times the derivative of the bottom, which is going to be 2/3 x, and then you take 1 away from 2/3, which gives you to the negative 1/3 power. All divided by the bottom squared. So then you get 2 times x to the 2/3 plus 1, which is 1 2/3, which is 5/3. And then you get minus 3x to the 2/3. All right, now you're going to get a negative 2/3, and then 2 plus negative 1/3 is going to be the new x power. So that's also going to be x to the 5/3. Negative 1/3 plus 2, because when you multiply powers with same bases, x squared, x to the negative 1/3, you add them. And then you get minus 3 times 2/3, it's going to be, a minus on the outside, minus 2/3 times a negative 3. That's going to make it positive, and you get 2x to the 2/3. And then this one right here, if it's a power to a power, you multiply those two. So it's x to the 4/3. Quotient rule is not working out so well. Maybe this problem is showing us that quotient rule is not a good idea. So now I can combine these like terms. 2x to the 5/3 minus 2/3 x to the 5/3 gives you 4/3 x to the 5/3. All right. And then minus 3 plus 2 is minus 1 x to the 2/3. All divided by x to the 4/3. Okay, so what can we do? What can we do? Well, we can take out a 2/3 on top. Factor it out. That would make this just 4x, because remember, factoring out is the same as dividing out, and when you divide, you subtract. So 5/3 minus 2/3 is 3/3, which is just 1, and then this is just going to be 4/3 x minus 1 over x to the 4/3. So you're going to cancel the whole 2/3 on top, and then this will be replaced with 2/3 on the bottom. So, my goodness, what more do we need to do to simplify this thing? 4/3 x minus 1 over x to the 2/3 power. I guess one thing we could do is get rid of this fraction inside here. So if I multiply everybody on top by 3 and multiply the bottom by 3, that would give me 4x minus 3 over 3x to the 2/3. So this is one way in which we can describe the final derivative for part A. Yuck, I did not like that at all. Let's try part B. Part B says, using the product rule. Product rule would look like this. What you would do is you'd bring your denominator to the top and change it from a positive exponent to a negative exponent. That's how you'd create product rule in this situation. So if you recall, product rule means first times the derivative of the second, which would be negative 2/3 x to the, take one away from that, negative 5/3, plus the second times the derivative of the first, which is going to be 2x minus 3. Now later on, you guys are going to be doing this quite a bit when we engage chain rule. I know I've been saying that phrase a lot, but it's true. Where you have to do some weird kind of factoring. I'm going to show you guys a sneak peek of what that looks like. The weird kind of factoring is to basically say, I'm going to take out an x to the negative 5/3. Okay? I'm going to divide out the smallest power here. So I'm going to divide out an x to the negative 5/3 here and divide out an x to the negative 5/3 here. That's going to give me negative 2/3 x squared plus 2x. It's going to be 6x over 3 plus 2x. And then this right here is going to be x to the negative 2/3 minus negative 5/3. Remember, when you do this division, it's really subtraction of the exponents. So it's going to be plus 3 over 3. This is going to be just 1x. So this becomes x to the 1 power times 2x squared. Or, sorry, it becomes 2x squared. And then you're going to multiply that here. Kind of complicated, yeah? So we can move this to the denominator of the fraction. This would become 1 1/3 or 4/3 x squared. And this will be minus 1x. Now if you notice, everybody seems to have some power of x. You can divide out the smallest of these three. So of 1, 2, and 5/3, what's the smallest number? It's 1. So what I'm going to do is divide by x to the 1 power. So that takes out this x. It changes the 2 to a 1, and then you would take 3/3 away from 5/3 to get 2/3. And now it's starting to look a lot like what we had over here. So then I could do the same simplification. That would give me 4x minus 3 over 3x to the 2/3, multiplying the top and bottom by 3. Same thing that I did over here. Now that was still pretty gross, but it seems like we did less work than we had over here. So we had that. Here's what happened when we converted it to product rule. Not as bad, but I mean, this probably wasn't a natural move for you guys. Okay, algebra first. Number 49C. Can you guys see that? Algebra first says take x squared divided by x to the 2/3, then take minus 3x divided by x to the 2/3. Oh wow, this creates x to the 2 minus 2/3. And this creates minus 3x to the 1 minus 2/3. All right, so y equals x to the, this turns out to be 4/3, x to the 4/3 power, minus 3x to the 1/3. The derivative, 4/3 x to the 1/3 minus 1x to the negative 2/3. Which ends up being 4/3 x to the 1/3 minus 1 divided by x to the 2/3 power. And I would say that's a legitimate alternate version than this one. I think this one looks a lot more elegant, but that one gets the job done too. And I think it's clear to say that this was probably our best approach when you have the option between quotient rule, product rule, and algebra first. All right, guys, this video went a lot longer than I thought, so I'm going to stop it now and give you part 2 here momentarily.